This conference will now be recorded.
Today we're going to discuss about something called as level of detail expressions, LOD, which stands for level of detail expressions, which are a type of calculations only in Tableau. Okay, so one thing that we know for very clearly that we have discussed yesterday also and in the beginning also is that everything in Tableau is at the level of detail on the chart. Now, what does it mean when I say that it is at the level of detail on the chart? All the calculations, aggregations, quick table calculations, everything is basically at the level of detail on the chart. Means it is controlled by the dimensions that we are using to build our chart, right? For example, if I take only profit, then that is the overall profit of Superstore. Okay, but when I take a dimension, then Tableau is partitioning the data per member in that dimension. It's taking the data and computing the sum of profit. Did we have to go and manipulate sum of profit aggregation for this? No, because automatically data is aggregated at the level of detail on the chart. So when we do not have any dimensions, zero dimensions means what? It is table scoped. Zero dimensions means we have not used any dimensions, which means the computations will happen automatically at table level of detail. Table level of detail means table scope, means entire data and your data connection is being considered. But now when I bring category, the data is automatically getting aggregated per member in that category dimension. For furniture, what is it like? For office supplies, what is it like? For technology, what is it like? Getting my point? Now, suppose I take region on top of this. Then it is going to further granularize my data and compute the sum of profit per region in each category. Did I go and tell to compute the sum of profit differently? No, it happened automatically. So all the aggregations, not just aggregations, even the calculations. So yesterday we saw profit ratio. What did it do when we computed profit ratio? We said sum of profit divided by sum of sales, right? So this is a calculation that we are doing. If I just take profit ratio, it is as good as doing it at row level and then summing it up. Okay, AGG. So now what I will do is I will put region. So automatically it is showing you the profit ratio computed per region, right? It is taking profit, it is taking sales and computing the profit ratio and showing you the profit ratio. Now you have to do little formatting to see the data. All right, so you're getting that rounded off. Why did it do this profit divided by this sales and give you this value? That is because we have region on the chart. So when you have region on the chart, everything is at the level of detail on the chart. So even the profit ratio is getting computed at region level of detail, right? Profit ratio is also getting computed at region level of detail. Everything in Tableau, be it calculations, be it quick table calculations, be it aggregations, everything is at the level of detail on the chart. So when I say at the level of detail on the chart, what do I mean? The dimensions on the chart will define it. Okay, this point should be crystal clear in your mind. Only then, whatever we are going to discuss subsequently will make sense. Now, what if you have to perform a calculation or an aggregation at a level of detail that would be different from the level of detail on the chart? Different from the level of detail on the chart. That is where LOD expressions will come into picture. Okay, and there are three types of LOD expressions available in Tableau. One is fixed, one is include, the other is exclude. Fixed, include, exclude. And this is the syntax that we use for the LOD expressions. We have the keyword, followed by that we have the dimension declaration, then there is a colon mark, then there is aggregation, followed by that you have the expression that you're trying to evaluate. Keyword, dimension declaration, colon mark, aggregation, and the expression that you're trying to evaluate. Okay, this expression could be something like sales, profit, or it could be a calculation, or it could be a calculated field, anything. So let us go ahead and look at the first level of detail expression, fixed LOD. It will compute values using specified dimensions without reference to any other dimensions in the view. Okay, it is going to compute the whatever you ask it to compute in the formula at specified dimensions level of detail without referencing any other dimensions that have been used in the view. Now, what does it mean when we say it is not going to reference any other dimensions in the view? It will not bother what dimensions you have used to build your chart. Okay. So fixed, remember, it will perform at the level of detail that you have specified in the formula. So whatever we are going to mention inside the formula, we are going to refer to it as specified dimensions. Okay, so whatever dimensions you specify in the formula, it will be computed at that level. So what does it mean? Let us see. Let's say I'm interested in looking at the sum of sales per region. So I created a text table showing me the sum of sales per region. For every region, sum of sales. This is the normal sum of sales only. No LOD here. Performed at region level of detail. Okay. Now, if I take state, what will happen? Automatically, it will compute the sum of sales per state. If I take city, what will happen? Automatically, because we have the chart built up to city level of detail, it is going to show us sum of sales is going to show us the sum of sales per city in that state, in that region. This is the normal behavior, expected behavior. But my requirement is that I have to see the sum of sales irrespective of the structure of the chart. I want to see the sum of sales per region only, computed at region level of detail itself. So what I will do is I will create a calculated field, which I will call fixed LOD only. Okay, so fixed at region level of detail, I would like to obtain the sum of sales. Fixed at region level of detail, I am trying to obtain the sum of sales. Look at the syntax. LOD expressions are enclosed in curly braces. That is one thing you have to note. Open brace Tableau will put once you select the keyword, but closing brace you have to go and put. This is the keyword. Followed by that we have the dimension declaration. This is the dimension that we have specified in the formula. So we will call this the specified dimension for our convenience. It is not a technical term. For our learning purpose, we are calling it specified dimension. Then we have a colon mark. Then we have the aggregation. Followed by that we have the expression. Okay. So what should this do? At what level of detail will the sum of sales mentioned in this formula be computed? At what level of detail will the sum of sales mentioned inside this formula be computed? Right. Can you all please try and respond to this question? At what level of detail will the sum of sales that you see in the formula be computed? All of you will agree, right? It is region level of detail only, it will be computed. So when I take this and use it inside the table, I will get the sum of sales computed per region itself. For each region, whatever is the sum of sales that is getting computed. Now, if I bring state into picture, you see what is happening to the result of your fixed LOD? irrespective of the dimensions, other dimensions on the view. It was computed at region level. It is computed at region level only. State came, it influenced the other normal sum of sales that we have, but it could not influence the result of the fixed LOD. Getting it? That is fixed. It will remain fixed at the level of detail that you have specified in the formula, but it will not change because of the other dimensions present on the view. Okay. Now, under fixed, we have two variants. One is where we do it at dimension level of detail. Other is where we do it as a table scoped fixed LOD. Table scoped and dimension scoped. You can also have multiple dimensions. We are not going to that level, but after you explore a little more on LOD, you can try multiple also. So dimension scope we have seen where it is performed at specific dimensions level of detail. Now what about table scoped? Table scope means what? When we don't mention any dimension anywhere, automatically it will work on the entire data in your data connection. So that would become table scoped. Okay, table scope means it is going to work on the entire data in your data connection. So here I'll give you a requirement. Let's say I am interested in looking at the average sales of superstore. Okay, now I want to put a reference line here on this graph. I'll tell you where it is applicable. So now these examples, just think of it from technical perspective. You need to understand how it works. Why will we use it? Where will we use it? We will discuss with some real-time use cases. Okay. Now this is average discount. Now I want a reference line showing me the overall average sales of superstore. What is the overall average sales of superstore? Let's check. The overall average sales of superstore is 229.9, and I want a reference line at 229.9. I want a reference line at 229.9, which is currently the overall average sales of superstore. It might change tomorrow, but whatever is the latest average sales of superstore, that should be indicated through the reference line. That is my requirement. So if I say fine, I'll go ahead and put an average line. I'll go ahead and put an average line. Do you think I'll get the average sales? Let us edit that and use a different color. And I'll label it with the value. What do you think this line is representing? It's definitely not representing the overall average sales. What does the reference line represent? Reference line will work on the data that is there in your graph. Here it is a pane scope, but we don't have any pane. So basically it's working on the data in the graph. Means what? These are the values, and the reference line has computed the average of these average sales values. It has taken the average of these numbers, and average of these numbers is 429. That is what it is showing us. Okay, so it is showing us 429, which is average of the values that are present on the canvas, that are represented on the graph. But what do we want? We want the line to represent the overall average sales of the business, which means I need to first of all get the overall average sales of the business without getting influenced by the dimensions on the view. So if I don't want to get influenced by the dimensions on the view, I will go for fixed LOD. I will call it overall average sales. So fixed at nothing, no dimensions there. When you fix it and then you do not give any dimension declaration, it gets computed at table level, means on the entire data present in your data connection. So average of sales fixed at no dimension declaration means entire data in your data connection show me the average sales. So what will this give me? It will give me 229.9. Okay, this I'm going to take to the detailed shelf by which it is going to be available to the chart. And now I will add reference line based on the value of the overall average sales, label it with the value itself, and use a different color. Okay. So you see how your line is 229.9 based on the fixed LOD, and this orange line is the result of the values on the canvas, on the chart. So suppose instead of subcategory, I have category. What will happen? Orange line will change. It is going to compute the average of these three numbers now. It's going to compute the average of, so 349.8 plus 119.3 plus 252.7 divided by the total number of observations 3 is giving me 307.3. But what about your reference line, which is the result of your fixed LOD? My fixed LOD line, reference line which came through fixed LOD, which was compute or created based on the fixed LOD computation, is not getting influenced by what dimensions I use on the graph. It is 229.9, it will remain 229.9. If I remove this, both of them are 229.9. Everything is 229.9 actually. Okay. So suppose I use category, then you can see again immediately. This line is not changing because this is the result of the fixed LOD. The orange line is changing, the average line is changing. Look at that. Average of these four values, 445, but this is 229.9 only. Average of these values, 120. This is 229.9 only. Getting it? So that is the purpose of a fixed LOD, when you have to fix something at a certain level of detail or at a table level of detail without being influenced by any other dimensions on the view. Then we go with fixed LOD. Okay. So with this understanding of what is a fixed LOD, let us look at a few use cases. Okay. So we need to create a histogram of orders. Basically, we need to find the number of customers X who made the number of purchases Y in total. Okay, let me explain the requirement first. Number of customers X who made Y number of purchases in total. So what uh, it is we have different customers in the business. And when would somebody become a customer of Superstore? If they have placed an order with Superstore, right? When would anybody become a customer? Only when they have placed an order with Superstore. So they would have placed an order. Okay. Now, this is not going to help me. I'm not interested in the list of orders. I want to see, let's say for now, I want to see how many orders were placed by each customer. Customer ID is there. How many orders were placed by each customer? So I'm interested in obtaining the distinct count of orders placed by the customers, unique count of orders placed by these customers. So when you do a right click on a dimension and take it to the canvas, right click and take it to the canvas, there will be one pop-up asking you which field do you want to drop. I want the distinct count of order ID. Okay, and then when you click on OK, now your dimension on this particular worksheet in this one particular instance is being treated as a measure, and the aggregation used is count distinct. Okay, if you're not able to do like that, no problem. You just take order ID directly. Okay, and then you convert it into a measure and use the aggregation as count distinct. That is also fine. Okay, if you're not able to do a right click and take it there, and then you're not able to do it through right click, then you can directly take it. Anything is fine. So what is this chart telling me? It is telling me about the unique number of orders, distinct count of orders placed by each customer, each and every customer, right? So this customer has placed 5 orders with Superstore. This customer has placed 9 orders. This customer has placed 4 orders. Again, 5 orders, 3 orders, so on and so forth. So we see that there are customers who placed 4 orders, right? Then there are customers who placed 5 orders. There are customers who placed 6 orders. So the requirement is not to get the number of orders placed by each customer. No, the requirement is to get the number of orders placed by number of customers. So what I need to understand is how many customers have placed only one order with Superstore. How many customers have placed 2 orders with Superstore? Overall 2 orders. How many customers have placed overall 3 orders? How many customers have placed overall 4 orders? So on and so forth, up to whatever is the highest number of orders that were placed by a customer. Okay, now how do I get that information? If I say, fine, you just want the distinct count of customers who place those many orders. So I will go and convert this to a measure and associate count distinct. It will not work that way. Because when we have two measures, one on the columns and one on the rows, we will get a scatter plot. And this is the distinct count of orders. Overall, we have 5009 orders placed with Superstore. And overall, we have 793 customers that Superstore has. It's showing us the total distinct count of customers, total distinct count of orders that they placed till date. So this is not going to help us, right? This is not going to help us. So what do we do about it? We make use of an LOD. All right. So I'll make use of an LOD. I will just obtain this information where I'm getting the number of unique orders placed by each customer through an LOD expression. Okay. So I'll go and create a calculated field for number of orders per customer. Please create this along with me. Number of orders per customer you create. So once you start typing in fix, you get the keyword fixed at number of orders per customer, right? So fixed at customer ID level of detail, we will try to get the distinct count of order IDs placed. Remember to close the curly brace. So I'll send you this formula on the chat. If you want, you can take it from the chat and please create this calculated field to obtain the distinct count of orders placed by different customers, each customer basically. Okay, hope all of you are ready with this calculation. So I'll click on OK. Now Tableau has taken it to the measures pane. Now when it takes to the measures pane, I'll clear this sheet. When it takes to the measures pane, what will happen? Again, it will get aggregated. All the values that were computed by the formula, they are now getting aggregated. And we're getting 5009. That is the total distinct count of orders placed by the business. Okay, it's not going to help us. We have, what is it that we are interested in here? We are not interested in aggregating that field. We want the values present in that field. If you want to look at the individual values present in a field, what should you do? It should be a dimension. A dimension, when you use it on the graph, you will see the individual values present in that field listed out. Unique values present in that field will get listed out. So that's what we want, that kind of a behavior. So we will take our calculated field and put it in the dimensions pane. When you take it to the dimensions pane, you see number of orders per customer is now in the dimensions pane as a dimension. So this, when I take it to the column shelf, number of orders per customer. So I see 1, 2, 3, 4, 5, so on and so forth, which means what? There are customers who placed only one order. There are customers who placed 2 orders. There are customers who have placed 6, 7, 8, 9, so on, 13 orders. None of the customers in Superstore have placed either 14 or 15 or 16 orders. The next number we have is 17, which means there are customers who placed 17 orders. Okay, that is how we read this information. Now, what is it that we want? We would like to know how many customers have placed one order only? How many customers have placed two orders, overall two orders? How many customers have placed three orders, so on and so forth. Means what? We need the distinct count of customers who have placed those many orders. So we will take customer ID. Either you drag and drop and convert it to a measure, or do a right click and take it. When you do a right click and take it, then it'll ask you what is the field that you would like to drop on the canvas. I want distinct count of customer ID. And when I do this, I will be able to see the distinct count of customers who have placed those many orders. So 12 customers are there who placed only one order. There are 34 customers who have placed two orders. There are 53 customers who have placed three orders, so on and so forth. All right. Now the tool tips, a little small thing is that tool tips, whenever you create any chart or any report for any project for any client, or even the projects given to you by the team, make sure that you work on the labels and the tool tips. Okay, don't just give it like that, the way it appears on the tooltip shelf. Edit it and make it more readable. Like if you give this kind of a tooltip, business people may not be able to understand what it is. Number of orders per customer, distinct count of customer ID. What is this? They may not really be able to understand it. So we'll make it easier for them to understand and read the chart. So when you click on the tooltip shelf, you will be able to edit the tooltip. Okay. So I want to neatly put it in a statement format that these many customers have placed. Then you have to insert value that should come based on the data point where you hover, value that should come from your graph itself, that you should insert these many orders. Okay, and whatever is the most important information, you can always make it, you can use a different color, you can use a different font style. So these things you can do and you can focus on it a little. Okay. So this is the data I want to show. So you see now 134 customers have placed 5 orders. Easier to read and understand. 9 customers have placed 4 orders. 53 customers have placed 3 orders. 34 customers have placed 2 orders. Then what? 12 customers have placed 1 orders. Doesn't sound good, no? 1 orders. It should be 1 order. 12 customers have placed 1 order. To this extent, you will have to fine tune. Now, how do I change that to order when it is 1 and orders when it is multiple? Okay, I'll create a calculation for that also. I'll create a calculated field just to decide whether I have to use order or orders in the formula. Okay, if the number of orders per customer is equal to 1, then I will say use order, else I will say use orders and end the statement. Okay, if the number of orders per customer is 1, then use order. Otherwise, you use orders and then you end the statement. This I will bring to the tooltip shelf, so it is available to the tooltip. Now I'll click on the tooltip shelf, and instead of putting orders here, I will delete and I will insert order or orders calculation that I created. Okay, now you see orders, 1 order. 12 customers have placed 1 order. 34 customers have placed 2 orders. Getting it? Like that you have to fine tune. So overall it is all fine. But when I come here to the last bar, again there's a problem. 1 customers have placed 17 orders. It should be 1 customer has placed, not customers have, right? Again a problem. So again we'll create one more calculated field. This time we are trying to decide whether we use customer or customers in the calculation. Shall I use customer or shall I use customers in the calculation? I will say if the distinct count of customer IDs is equal to 1, then you use customer. else you use customers and you end the statement. Getting it? So now this I will take it to the tooltip shelf again. It's available for the tooltip shelf, so I'll go there and instead of customers, I think this will remove. Have also I'll remove. Instead of customers, I will just insert the calculated field customer or customers. Let Tableau decide what to use. So 12 customers have placed one order. 34 customers placed two orders. 134 customers placed five orders. Fine. Then here you see one customer placed 17 orders. This is the extent to which you will have to refine and fine tune your tooltips, and then the labels, the titles of the axis, which will make them easier for the business people to read and understand the graph that you have created. Okay, so that is about one use case. Let us do another use case using fixed LOD. Here, take 2 minutes, read this problem statement and take two minutes. Decide on what will be your approach. Think of, if at all you only have received this project, this requirement from your client, you're working with a client and they have given you this kind of a requirement. What will be your approach? I'm not asking you to give me the formula or algorithm, nothing. Think of it like, what will be the flow chart. Suppose you are asked to draw a flow chart for this. What will you do? What will you do first? What will you do? What is the next thing? What is the next thing and the next thing? Okay. 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 We can create. Okay. So to get the customers who have purchased second time, how do you identify whether they have purchased second time? All right. I mean, okay, at least you are thinking in that direction. That is nice. Both of you, Ibrahim and Rani. All right. So let's go ahead and solve it. So what is it that we are trying to understand or get here is we need to get the percentage of customers who made a second purchase within 6 months of making their first purchase with Superstore. So basically, we are trying to check customer loyalty. Okay, people who come to the store, are they coming back again and again? And how much time is it that they are taking between two purchases, between the first and the second specifically? So, what percentage of customers made a second purchase within 6 months of making the first purchase is the requirement here. Okay, so what we will do is first we will try to obtain or get the first purchase order date. When did that customer make the first purchase with Superstore? Okay, then we will try to obtain the second purchase date. When did that customer make a second purchase with Superstore? Now, once you know the first and the second purchase order dates, if we get the difference between these two dates, and if the difference is less than or 6 months or less than 6 months or more than 6 months, we will check that. We'll check the difference between the two dates. Depending on the difference, we will put it into one of the buckets. People who have taken more than 6 months to make a second purchase, people who have taken less than 6 months to make a second purchase, people probably who never made a second purchase at all. That is also one scenario we have to consider it. We cannot just assume that everybody will make a second purchase, because in the previous chart we realized that there are 12 customers who placed only one order, which means there are 12 customers who never made a second purchase with Superstore. This kind of a scenario also is possible, and you need to handle that also, right? So people who never made a second purchase. Once you can bucket the customers into three categories like this, getting the number of customers in each bucket and then changing that to a percentage would be easy. Okay, so we will first obtain the first purchase order date, means the date when the customer might have placed the first order with Superstore. Okay, let's get the first purchase order date. Customer, when did they make their first purchase? Now, how do I get when did they make their first purchase? Each customer has placed multiple orders. When did they make the first purchase we are interested in? So what we will do is we will show the exact date. You can customize it and say that you want to see the exact month, day, and year. So on 31st March 2011, the first order was placed. Then on 15th September 2011, another order was placed. Then on 4th October 2012, another order was placed. So we can see the dates. They're already in ascending. Now, how do I get the date when the customer has placed the first order with Superstore? If I can get the minimum of that list of dates when the customer placed an order, minimum of that list, that will be my first purchase order date. And this has to be obtained for every customer, it has to be obtained. So we use LOD. If I just say get me the minimum order date from this entire table, whatever is the minimum, it will show me that. That's not what I want. I want the minimum for each and every customer. So I will use fixed LOD. So we'll create the first calculation. Let's call it first order date or first purchase order date, whatever is more appropriate, you can use that. I'll say fixed at customer ID level of detail, obtain the minimum of the order date, minimum value present in the order date column. Okay, fixed at customer ID level of detail, we are trying to obtain the minimum of the order date, of the dates that are present in the order date field. So for every customer, you will get the minimum order date. Please create this, all of you. I'm sending you the formula on the chat. This is your first purchase order date. Okay, I hope all of you are ready with this formula for the first purchase order date or first order date. Okay, now let us take it to the canvas. And let us look at the date that we have obtained by customizing it to show month, day, and year. So you see, for this customer, we have obtained the first purchase order date as 31st March. For this customer, 21st of April. For this customer, 4th of May. So we have obtained the first purchase order date successfully. No problem. Now we need to get the second purchase order date. Okay, we need to obtain the second for this customer. This is the second purchase order date. For this customer, this is the second purchase order date. For this customer, this is the second purchase order. Now, how can I pick up the second purchase order date? Okay, there are different ways of doing it. What I will do, I will tell you. I will look at the dates which are greater than the first purchase order date. I will look at the dates which are greater than the first purchase order date. And from the dates which are greater than the first purchase order date, I will pick up the minimum of that list. Getting it? I will look at the dates which are greater than the first purchase order date. So this is equal to first purchase order date, it will get ruled out. From that list, I will pick up the minimum. And that I will do for each and every customer. Okay, so let me build a formula for this logic which I'm talking about. Create a calculated field. This is the second order date. So if the order date is greater than the first purchase order date, then only I am interested in it. Then only I am interested in that order date. And finish. So what will this give me? It will check. Okay, 31st March is equal to 31st March, so that record will not be considered. 15th September is greater than 31st March, so that will be considered. 4th October is greater than 31st March, that will be considered. 4th March is greater than 2013, greater than 31st March 2011, that will be considered. And this will be considered. But do we need all the dates which are greater than the first purchase order date? We don't need each and every date that is greater than the first order date. We need only the minimum of that, right? We need only the minimum of that list. So we will simply wrap this whole thing around minimum. Finish. I'll wrap this whole thing in minimum. So what am I getting? I'm getting the minimum of those order dates which are greater than the first date, first purchase order date. But this has to be computed for each and every customer. So that is where we will bring LOD into picture. Fixed at customer ID level of detail, you do this. Fixed at customer ID level of detail, you do this. Obtain the date. Okay, second purchase order date. So I'm sending you the formula on the chat window. All of you please create this calculated field, and whatever name you have given to your calculation where you computed the first purchase order date, use that over here. Don't just give first order date, it will throw an error if you have given it a different name. So whatever name you have given to your calculated field, that should be used here. Okay, I hope all of you are ready with this formula. Let's click on OK. And let's check whether Tableau is doing the right job for us or not. So I'll take second purchase order date and place it on the canvas. No, it's not case sensitive. Means whatever names you're using, they are case sensitive. If you are using first order date with O small, and if you give capital O, then it will not recognize the field. Okay, so you have to take care of that. More, and I will customize it, and I will show the day, month, and year. Month, day, and year. All right. So good. For this customer, we are getting the second order date. For this customer, we're getting the second order date here. So we're getting the second order. Now, what do you think will happen for customers who never made a second purchase at all? It's possible that we'll have customers who probably never came back and made a second purchase, right? When the date does not exist, then they never made a second purchase, and that date therefore does not exist. What do you think will be in that field? Second purchase order date. There's nothing. Null. It should be null. Okay, let's check. Correct. It should be null. Here you see, it does not exist. Nothing. So nothing means null. Blank. All right. Now we have to get the difference between the first and the second purchase order dates. And we need to obtain that difference in what units? What should be the date part here? Any thoughts? Right. Months, right? We have to obtain the difference between the first and the second purchase order dates in number of months, right? Because we are interested in looking at the number of months taken to make a second purchase. So we will build a formula again, create a calculated field for the number of months taken to make a second purchase. Months to second purchase we are creating. What we will do is we'll get the difference. So we are using date difference function, get the difference in number of months between the first purchase order date and the second purchase order date. Get the difference in number of months between the first and the second purchase order date. So this you build yourself. Um, I'm not sending it on the chat because whatever name you have given to your calculated field for the first purchase order date, that should be given here. Whatever name you have given to your calculated field for second purchase order date, that needs to be given here. Please create this all of you. Start of the week by default will be depending on your system locale. Usually it is Sunday, but if you have to change it, then you can change it by using that option. Like let's say you're working for an Arab client, then for them start of the week is Friday, no? So that would change. But here you can leave it. We don't have to worry. Okay, I hope all of you are ready with this calculation. Let's click on OK and let's check whether Tableau has computed it well or not. Okay, so it's computing, and here where we don't have the second order date, obviously we will not have the difference also. So it's all working fine. Now, depending on the number of months that Tableau has taken to make a second purchase for each customer, we will have depending on the number of months that each customer has taken to make a second purchase with Superstore, we will put them into different buckets. People who have taken less than 6 months, people who have taken more than 6 months, and people who never made a second purchase at all. Okay, so let us create a calculated field to write that logic. Okay, so we are trying to understand the
Bhargavi, here 0 will also be less than 6, right?
Yeah, yeah. 0 is also a valid number. It will come under less than 6. 0 means what? 0 means they have
We
made
should
a
not
second
consider,
purchase.
right?
No, no, we should consider 0 is valid. 0 means they made the second purchase in the same month when the first purchase was made.
And how
See,
about if someone has not made any second purchase?
that will be
What is
null, no?
the difference?
Null. That is what we've been discussing, no?
Okay.
Right? See, if they have not made a second purchase, the second purchase order date
Okay.
does not exist. If that
Okay.
does not
Okay.
exist, the difference does not exist. All
Sure.
right.
Sure. Yeah. Yeah. Just got confused.
Ah, okay.
Thank you.
0 is a valid number. 0 means the second purchase was made in the same month when the first purchase was made. So both of them in the same month. All right. So you will have to create this calculated field where we are categorizing the customers depending on their. Wait, I did not save it, I think. So we will call it
months.
repeat purchasing. Okay. If the months that they have taken to make a second purchase, okay, is greater than or equal to 6, then I'm saying more than 6 months. So I'm taking even greater than 6, equal to 6 in this category. Okay. Light. Else if months to second purchase is less than 6, then less than 6 months. Else we are saying means it is not greater than or equal to 6. It is not less than 6. Then the only other option left out is it is blank. So no second purchase. And we will end this. No second purchase at all in that case. Okay. So all of you, I hope, have built this formula. Whatever name you have given to your calculated field on your machine, use that name here and click on OK. Now we'll build the actual chart. This is all just rough work. This is not our chart. This is the chart that we will build. So we have repeat purchasing under which we have put different customers in 3 buckets: less than 6 months bucket, more than 6 months bucket, and no second purchase bucket. Now what is it that we need? We need the number of customers in each bucket. We need to obtain the number of customers in each bucket. So we will just do a right click on customer ID, drag and drop it in the on the columns shelf. Say that you want to look at the distinct count of customer IDs. Okay, distinct count of customer IDs. So you can see the distinct count, but we are not interested in the number of customers. We are interested in the percentage of customers. So what we'll do is we will go here and change this to percent of total. That will give you the percentage of customers who have made a second purchase within 6 months of making the first purchase. Finish. All right. Any questions on this use case? I hope it is clear to all of you. Otherwise, let me know. We'll discuss. That was about fixed LOD. So we know that there is a table scope fixed LOD that we can write if required. We can write a dimension scope fixed LOD by specifying the dimensions and how you use it. Now, fixed means it is just fixed at whatever level of detail you fix it. Okay, I don't see any questions coming. I hope the use case was clear. Let's take a break for 10 minutes here. After the break, we'll continue our discussion. See you in 10 minutes. Thank you.
This conference will now be recorded.
So the next level of detail expression that we are going to look at is include LOD. Okay, include is something that will compute the values using the dimensions that you have specified in the formula. Okay, specified dimensions. In addition to that, it will also consider whatever dimensions are in the view. It will also consider whatever dimensions are available in the view. Okay, so what would include do? Include will will look at whatever dimensions you have on your view. In addition to that, it will also consider the dimensions that you specify in the formula. So specified dimensions are also taken into consideration. So at what level of detail will include work? View level plus the dimensions that you have mentioned in the formula. So it will it will consider all the dimensions that you have on the view. In addition to that, whatever you have mentioned in the formula where you use the include LOD will also be taken into account. So basically the computation will be at a more granular level, at a more lower level of detail or a more granular level compared to the view level. Okay, now the example that we will see is for you to technically understand what happens behind the scenes when we write an include LOD expression. Then we will see a real-time use case on it. Okay, so calculate the average of sales per state for each subcategory of products. The catch here is that state should not be present on the view. State is not supposed to be present on the view. So if I have to take state also and do it, suppose, how will I do it? For different subcategories, I will look at the information for different states and I'm looking at the average of sales information here. Okay, so that is quite simple. I can get it like this: average of the sales information for every combination of subcategory and state. Let me copy this data and paste it for my reference. We will refer back to it later. But here what the catch is that we should not include state in the picture. Without using state in the picture, we have to create a chart like this. So let me create a bar graph. Okay, now without bringing state onto the canvas, we need to compute the average sales by taking state into account. So how do you introduce a dimension without bringing it onto the chart? We will use LOD expression. So I will create LOD, include LOD. What I need here is I want to include state while computing the average of sales information. Here I request all of you to respond. How, at what level of detail will this average sales that I have written in the formula be computed? At what level of detail will the average sales which is specified in the formula be computed? We are using include. So keep that in mind. We are using include. If it was fixed, then it would be fixed at state level without being concerned about whatever is there on the chart or the view. But we are saying include. Include means it will look at what you have on the graph. On the graph, what I have subcategory. In addition to that, what I have in the formula, what did I specify in the formula? State. What I have specified in the formula is state. So it is going to take the dimension specified here, state. So the average sales which we have written in the formula will be computed at subcategory and state level of detail by taking both the dimensions into account. So when it takes both of these dimensions into account, it has computed different values, right? For every combination of subcategory and state, it has obtained the average of sales. Now those values are there in this field, which when I use it on the canvas are getting summed up. Those values are getting summed up, but I want the average of those values. So it is getting summed up to be 9010, 10,102, etc. But that is not what we want. We want the average of those numbers also. So I will say, get me the average. You see how the averages are different when we include state. So what is happening is, remember, now we are computing the average sales for every combination of subcategory and state. Okay, so Tableau will go to accessories. There it is going to look at the data for each state. So here, what Tableau is doing is, what basically is happening is this. When we were doing it at subcategory level, the first set of bars which we're giving you at subcategory level, let us say accessories. For accessories, the average of the data in the sales column is 215.9, which is rounded off to 216. This is something we know. Okay, but what about this 209? How did this come up? Right. Here we are also considering state for the combination of subcategory and state. So let us say we are in accessories. Now we are looking at the state of Alabama. So for the combination of accessories and Alabama, the average of the data in the sales column is coming up to be 387. So for the combination of these two states, it is 387. Accessories with this state is giving you an average sales of 387. Then accessories with the combination of the next state, Arizona, together are giving us the average sales of 154.3. Okay, we are getting the average sales of 154.3 for this combination. Like that, for each combination of subcategory and state, Tableau is actually that formula. The include LOD is computing the average sales like this. And then when we take the include LOD to the canvas, what did we get? We got summation of all these values. Summation of all these values is what it gave us, 9,190. But we want the average. You take the average, it is 208.86. That is nothing but 209. Okay, that we are looking at, 209. Technically, what happens when we use an include, at what level of detail it will go and perform the computation, how it is going at a much more granular level and then working on the data. Is it clear? Where will such a logic get applied? We will discuss that. But technicality is something that I want you all to understand in this example. No, any combination you go, you get the same result. See, whether you go to a state and then look at different subcategories information, or when you go to subcategory and look at different states information, both will be the same. So it's either way you can do it. Okay, so okay, I'll explain one more time. How did we get the first set of bars? The first set of bars on this graph, they are representing, okay, the first set of bars here are basically representing the average sales per subcategory. So how is average sales per subcategory computed? Tableau will go to our data source. Okay. So let us say it has selected accessories as the subcategory. For accessories subcategory, it is computing the average of the data in the sales column. Average of the data in the sales column for accessories subcategory is coming up to be 215.9. That is what we are seeing as 216 here. Okay, then comes appliances. For appliances, what is the average sales? Then we will choose the subcategory as appliances, and the average sales, average of the data present in the sales column for appliances when you check. It is 230.7, rounded off as 231. So the first set of bars are clear, right? How did the average sales computed? It is just the normal way that Tableau will do everything at the level of detail on the chart. Now our concern is, how did it compute the average sales in the formula? We wrote an include LOD expression. Now we are trying to figure out, how did this average sales get computed? What we have written in the formula. This is getting computed by including state. And what will include do? It will take whatever you have on your graph. In addition to that, whatever you have put in the formula, both will be taken into consideration. And then the aggregation or calculation is performed. So average sales here is going to get computed at combination of subcategory and state level. Okay, so how is this data getting computed is, now Tableau will go to the database under, let us say, accessories. Under accessories, it is checking for the data from each state for the combination of subcategory accessories and the state of Alabama. Okay, it is checking what is the average of the data in the sales column. That average is coming up to be 387.1. So now it is not working just at subcategory level, it is working at the combination of subcategory and state level. So for every combination of subcategory and state, it is going to compute the average sales for every combination. How many such combinations we have? We have 17 subcategories and we have 49 states. So for every subcategory and state combination, subcategory accessories with state Alabama, average of sales is so much. Subcategory accessories and the state Arizona, average of sales is so much. Subcategory accessories, state Arkansas, the average of sales is so much. So it is computing the average sales. This is what your include LOD is doing. Is it clear? What the include LOD is actually going to give you in return? This is the data. For the combination of subcategory and state, it is computing. No, it is not getting filtered. It is the amount of data on which Tableau is acting. I am showing you through filter in an Excel, so it is easier to understand. This is the amount of data on which Tableau is working or acting upon. Okay, now when it is acting upon this amount of data and computing the average sales like this, this is what is present in your include LOD now. That is what is present in your include LOD. Okay, that is what is present in your include LOD. Now we want to get the average of those values. So I'm telling, give me the average of the data present here. So average of all of these values is nothing but 208.8, which is 209. Now sometimes it may be low, sometimes it may be high. It depends on how you have the data. Okay, it's not necessary that if you're including and granularizing, you will always get a lower value. It is also possible you'll get a higher value. Depends on how that data is present. Okay, what kind of values we are dealing with, it would depend on that. Okay, now let us look at one real-time use case on how this kind of a weird thing is going to help us. It's quite interesting actually, though it may appear weird now that, okay, why are we doing this when state is not there in the picture? When you're not going to bring state into the picture, why should it even consider state? Right? Yeah, it considers all the states. Yeah, it considers all the states and subcategories combination. Okay, so let's get connected to coffee chain for the use case. Get connected to coffee chain Excel, all of you. And let us look at the use case here. So we will be using coffee chain. Okay, display the difference in actual and target profit. Display the difference in actual profit and target profit per state for coffee chain business. Indicate the percentage of products that are above the target in each state. Okay, so we have to show the difference in the actual and target profit per state for coffee chain business. So for coffee chain business, this business is active in 20 different states in US. In every state, they have made some profit. But even before the business starts, every state is given a target. Okay, there are some target profits that they are supposed to achieve, which is there in the budget profit field. Okay, when you compute profit minus budget profit, let us get the difference. So I'll do profit minus budget profit. Okay, and let's see the difference. So 31,785 minus so and so is 3,405. So we are showing the difference. First requirement is done. Display the difference in actual profit and target profit per state for the coffee chain business. So for every state, we showed what is the profit, we showed what is the budget profit, and we are also showing what is the difference between that profit and budget profit. So if the difference is positive, what does it indicate? If the difference is positive, it means that state has performed well. It went beyond the expectation by so and so value. If the difference is negative, what does it mean? That state could not reach the target given to it. It missed the target by so and so value. So either overperformed or underperformed. Till here, is it clear to all of you what is happening? What is it that we are doing? Any questions over here? Anybody? For the first requirement, we are trying to display the difference in actual and target profit for each state. Difference is positive, means the state has performed well by so and so value. Any question? Check your connection, audio connection. All right. So we understood this. But here the requirement, the twist in the requirement is that, we also need to indicate the percentage of products which have gone above target. We need to indicate the percentage of products which have gone above target over here. Without bringing product into the picture. That is another catch. You need to show the percentage of products which have gone above the target in each state without bringing product onto the chart. So if California has performed so well, can we be sure that each and every product that was sold in California did well? All the products sold there, 100% of them did well. That is why this is the kind of result California is seeing. May or may not be true. Maybe all the products did well. Maybe only certain products did well. Certain products did not do well. But overall, when you look at state level, it is doing well. We don't know. And if a state has missed its target, can we say that all the products did not do well? Again, we cannot generalize and say that if a state is not performing well, all the products are not performing well. Maybe none of the products met the goal. Maybe certain products managed to reach the target, but it was not good enough, to overall take the state itself to, meet the target. So we cannot comment. When the chart is at state level and I have to comment at product level, I cannot do that. If I bring product onto the graph, then I can check. All right, California, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 products are being sold. Out of 12, 1, 2, 3, let me turn off the tooltip. Quite irritating they can be sometimes. Okay, 1, 2, 3, 4, 5, 6, 7, 8 have gone above target. So it's like the exam was for 12 marks and we got 8 marks out of it, approximately 66%. So 66, 67% of the products have done well in California, right? we need to get this information and tell that 67% of the products in California have gone above the target. And we should do this without bringing product into picture. So how can you make a dimension influence your chart, influence your calculations without bringing it onto the canvas? Include it, right? That is the purpose of include. We will not bring the dimension onto the chart. However, when we are performing the computation, when we are calculating the difference, we are going to include product. So when I'm computing this difference, if I include product and obtain this information by including product, then I can check whether it is positive or negative, and then I can decide how many products are above target, and then I can tell you the percentage of products that are above target. So I will have to use include. This product I will not introduce at graph level. I will introduce it in the formula. So while difference by product, okay, create this all of you. So what we are trying to do is, by including product, we want to get summation of whatever we have already computed difference. So we already have the calculated field, no? Profit minus budget profit, you use that here. Or you can write here only, you can write profit minus budget profit. So whatever is convenient for you, you do it. Okay. Sum of, either you write the formula here, whatever you have used in difference, profit minus budget profit, or you write the expression only. It is okay, anything is fine. So what are we doing? We want to include product and compute the difference between profit and budget profit. So this difference between profit and budget profit will be computed at what level of detail now? Whatever is down the view state and whatever is in the formula product. In every state, it is going to check the performance of different products, and there it is going to compute the difference between profit and budget profit and tell us what is the difference. Okay, please build this formula, all of you. Build the formula for difference. Okay, now this difference will basically give us the information by also including product. We anyway have product on the canvas. For now, I'm keeping it to explain. Okay, so what I will do to obtain the number of products which are above target is, okay, where the difference is greater than 0, I will assign that a number 1. Okay, what I'm doing is I need to obtain the number of products which are above target. For that purpose, to get the number of products above target, what I will do is I'll check if the difference by product is greater than 0, then I will assign number 1, else I will assign a number 0 and do an end. Create this, whatever name you have given to your calculated field, use that and do this. So what will happen? We will check the difference by product. If it is greater than 0, we are giving that product a number 1. If it is less than 0, we are going to give that product a number 0 in that state. Build this calculation. LOD will work on MS Access file also. It will work. MS Access, you should get fact table, product table, location table, everything you bring, and it will work. Because we need the data from all the tables, because we have product information in the product table, we have the sales and all the other information in the fact table, we have state information in the location table, so you need to access data from everywhere. It will work. Okay, now we have number of products above target. You see, what did we do? This is what we did. Where the difference is positive, we are giving it a number 1. That is what we have done. Where the difference is negative, we are giving a number 0. Now, if I can sum up these ones and divide it by the distinct count of products being sold in each state, I can get the percentage, right? How do you get the percentage? Sum up all the ones. 8 divided by what is the total distinct count of products being sold in that state? 12. 8 by 12 we want for California. The same thing if it is the state of, let's say, Connecticut. Total number of products above target is 1 plus 1 plus 1, 3. How many are being sold? 7. So 3 out of 7. That is what we need to obtain. So we will have to build a formula for that. So now I'm going to get the percentage of products above target. Okay, that will be the summation of the number of products above target divided by the distinct count of products being sold. Where? In each state, because state will be in the picture, no, end of the day. Number of products above target. Okay, what went wrong here is when I'm computing the number of products above target, we will just look at the difference by product. Okay, make that fix. Then we will check if the summation of the number of products above target is summation of the number of products above target divided by the distinct count of products which are above target. So in your number of products above target, remove the summation, and then you put that in percentage of products above target. You can see now the answer. First, products above target. Let us remove product from the picture.
And can you show
So you
the
see,
formula once again?
This is number of products above target, okay, which I'm sending you now on the chat. The next formula is the percent of products which are above target. Next formula is the percentage of products which are above target. Okay, number of products above target divided by the distinct count of products being sold there. That is percentage of products above target. And now you remove product from the row shelf. The requirement itself was such that we should not have product here, right? So once you remove the product from there, you can see the percentages. Number of products above target, percentage of products above target. Now this difference and all you don't have to show actually. Even number of products not required. We have to show the difference and we have to show the percentage as per our requirement, and we have done that. So all the calculations, I hope you got it right. Try do this. I'll give you all a couple of minutes, then we'll proceed to the next LOD. All right, I don't see any questions. I hope this is clear to you. Now we will proceed to the next example, which is on exclude LOD. Okay. I understand that LOD itself is, the most difficult concept in Tableau. So even if you're not getting it right away, it's okay. You can practice and, with a few examples, if you try, it will come. Next, exclude is this. It's basically the opposite of include. Okay, if you have understood include, you will automatically understand exclude. What exclude will do is, it will subtract the dimensions that you specify in the formula from the dimensions that are present on the view. Okay, so what is include doing? It is including the additional dimensions from the formula. Exclude will do it the other way around. From the view level, it will subtract the dimensions that you specify in the formula, which means the computation is going to be happen at a higher level of detail, at a more aggregated level of detail compared to the level of detail on the view. View would be granular, but your computations will be happening at a higher level, okay, compared to the view. So if you just remember this, it is sufficient. Fixed means at specified dimensions level. Specified dimensions meaning whatever you specify in the formula. Include means whatever you are including, whatever is there on the view plus whatever you have mentioned in the formula. Exclude means from the view, it is going to remove what you mention in the formula. Okay. For example, let us say I want to look at the sum of sales of Superstore. This is the overall sum of sales of Superstore. We know that we have not used any dimension, so that is the overall sum of sales of Superstore. Now I will do an ad hoc calculation. You can also create a calculated field. Here I'm doing an ad hoc. Exclude region and give me the sum of sales, I will tell. Please create this. We're telling Tableau to exclude region while computing the sum of sales for us. Okay, we're telling Tableau to exclude the region information while computing the sum of sales for us. Okay, create this and you will see the value that you will obtain by excluding region. Why are both one and the same? Now I clearly excluded region, I'm getting the same value. Whether or not I exclude the region, why are both one and the same? Because what will exclude do? From the view, it will subtract the dimensions that you have specified. Now in this case, we don't have anything on the view. When we don't have anything on the view and it is a table scoped computation, what will it subtract from? There's nothing to subtract from. Okay, that is what happened. Suppose I bring region into picture now. Suppose I bring the region dimension into the picture. What will happen to the first set of bars indicating the normal sum of sales? They are showing you the sum of sales per region. They are showing you the sum of sales that we are obtaining per region. And what about the other set of bars, which are the result of your exclude LOD, where we have clearly excluded region and then tried to compute the sum of sales? At what level of detail is it giving you the sum of sales here? Now come here to this definition. On the view, we have region, from which we are subtracting region by mentioning it in the formula. Region minus region is 0, that is no dimensions. No dimensions means it will work on the entire data in your data connection. So it is giving you the overall sales of Superstore here, repeated across all the regions. Same value repeated across all the regions. Okay. Now let us take category into picture. What will happen to the first set of bars? It is going to show you the sum of sales. It is going to show you the sum of sales per category in that region. So in central region, what is the sum of sales for furniture? In central region, what is the sum of sales for office supplies? In central region, what is the sum of sales for technology? But what about the second set of bars? Can you answer this question, all of you? How did Tableau compute the sum of sales for this in the second set of bars? How did Tableau compute the sum of sales in the second set of bars here? Per category, because, right, because what are we doing? On the chart, we have region plus category, that is the view level, from which we are subtracting, what did we subtract? Region. By mentioning it in the formula, we have subtracted region. That leaves us with category, which means the sum of sales in the second set of bars is basically showing you the sum of sales for each category. So that is why furniture, same value, furniture. Across all the regions, furniture has the same value. Getting it? So that is an exclude LOD. Okay, here we will stop the discussion. If you have any questions, I will take up. Otherwise, we stop here and I will see you tomorrow for the next session. Tomorrow,
Yes.
remember, 7 o'clock, there is a session on level of detail expressions, which is a webinar. If you want, you can attend that. And then 8 o'clock is our regular training. It may get a little delayed tomorrow by 5 or 10 minutes. Once I complete that webinar, I will log into this session. Okay.
Bhargavi, yes, I'm getting that error as level of detail expression are not supported by MS Access data source coffee chain.
Really? Maybe they removed it because earlier I was able to do using MS Access this use case.
Mine is 2019 version of Tableau, 2019.4, I think.
There are some data sources which don't support LOD. There are
Okay.
some data sources which don't support it. Maybe MS Access is. So do you have Excel version of Coffee Chain with you?
I think I'm having it. I have downloaded with the data sources, but I'm using only MS Access as of now. So I'll change it. I'll change it to the Excel version and I'll try.
Okay, but I will also check and get back to you if there is anything like that that it's not supporting. I will tell you. Okay.
Okay. Okay.
And the use
Thank
case on Exclude, we'll do it tomorrow. Okay, here Ibrahim is telling me that he's using Access and it's not giving any issue. Tomorrow is not the last day for the course. Yeah, we have gone a little slow actually. We will need one more day. So tomorrow will not be the last day. Ideally, tomorrow is supposed to be the last day, but we will complete it on 13th. Okay, after the weekend, Saturday, Sunday, we'll meet on 13th and that will be the last day. Okay. Tomorrow is not the last day. It's not doing. What is it doing? It's not showing me the include keyword only. So I think serial number along with the dimension names, you can use index function to show the serial number. Index function will help. Tomorrow in that quick table calculation webinar, I'm planning to explain in detail about index and rank and the difference between them and all that. So maybe you can attend that, Mayur. Tomorrow 7 o'clock session. I'll discuss about it. Okay. Ibrahim, I didn't get you. Small time slots means?
You're getting less time for assignments, you're telling, for doing the assignment. Oh, okay. No. For discussing the assignment questions. You just ping me, Ibrahim. In the class, I think it's becoming a little difficult because we are already late on our regular schedule. We are going to extend the training by a day. So further, it cannot be extended. So you ping me on the WhatsApp group, or I'll give you my email ID. You email me or WhatsApp me. Anything is fine. Any of you, if you have questions on assignments, you can drop an email to me. Mention that you're from 360 DGTMG and mention the module number and the question number where you are stuck or where you're not able to do it. I will help you. Okay. All right. Thank you all. That's it from my side.